So the answers to the problems to begin with are as follows. 265 is 379. So I gave you problem 265 is 379. Anybody have, we won't go through any of these until we go through all the, I go through all the answers, and then you can double check. 273 is 26.4. 273 is 26.4. 277A is 2 liters. C is 109 kPa. 109 kPa. 278, the answer in the book, is, I think, 0.0157. Let me double check that one. But let me check that one again, because I wrote that down based upon what was in the book in scientific notation. And I'm going to double check that one just to make sure. 0.0157 moles is what they have. So there's 5 problems, and I will do any of the 5, all the 5, 2 of the 5. You guys just let me know. The first 2 were dealing with the combined gas law, which is pressure 1 times volume 1 over temperature 1. And then N equals P2 times V2 over T2. So
What was the answer to 265?
265 was 379. And they're doing everything significant digits. So I mean, if you're taking it out further or not as far, that could play a role in your answer and how far you're away from it.
Can you do 277C and 278?
Okay, so 277C has to do with the ideal gas law. Okay, so if you have your book, it's kind of nice to see what information you're being given. So, problem on page 277C. Now, it could be that you use the wrong constant. So, first of all, your R should be your R should be 8.31, right? 8.31. So that's the one you should have used. If you use 62.4, that would give you a wrong answer. If you use 0.0821, that would give you a wrong answer.
They're using 18 not kPa.
But they wanted 277C.
Oh, I was looking at 278.
That's kPa. So they wanted in kPa. So if you have an answer in atmospheres, we can see if you did it right. But that's a common mistake that would be made on that. Okay, we'll go ahead and do it. 277C, these are nice because everything's all lined up for you. If you were gone yesterday, we are using this equation, PV equals nRT. For those who were gone yesterday, the N represents moles. So moles is just the number of molecules that are in that sample. The more molecules, the more pressure. The more molecules, the bigger the volume if pressure stays constant. So as you increase moles or decrease moles, what will happen is the volume, the pressure, that changes because you got more molecules packed in, more pressure. Less molecules, less pressure. Okay? If volume stays constant. So in this situation, we're looking for pressure. So P equals nRT over V. Correct? So our moles that we're given is 0.815. Might run out of room here. Didn't give myself much room. The R value, since it's in kPa, is 8.31.
What does R stand for again?
The constant. There's 3 constants depending upon what pressure they want the answer in. If it's kPa, I would write down in your notes, because I had 2 people today already come up and say, what page is the R values on? Okay? So, real quick, R, if it's kPa, like this one, it's 8.31. So So if it's in kPa, that's your R value that you would use. If the value is in atmospheres, is 0.0821. And that's in atmospheres. Okay, and that's not the only units, but that's the units that we're concerned with because that's the only thing that changes. And if the R is in millimeters of mercury, it's 62.4. Or torr. Okay, so write those down. Now, you can write those down on your periodic table if you want. Okay, because you'll always be given those. I'll never have you memorize those. So a lot of times we always have periodic table with us. If you want to write the R values down on there, be my guest. It's not going to cause me any problems of you having extra information. Okay, so we got 8.31, and then our temperature is in Celsius of minus 20. So we add that to 273, so it's 253. And again, I'm running out of room because I didn't let myself have much room. So, okay, divided by the volume, and the volume is 15.7 liters. Has to be in liters. Those who were gone yesterday, and just a reminder for those who were, everything has to be in liters. You have it in milliliters, you got to convert it. Everything in the ideal gas law has to be liters. Okay? Any questions on that? I'm not going to do the work, but it should come out to be the answer once I gave. Any? Yes, Brady?
Well, can I ask to go over?
Yep, sure can.
Can you go over number 273?
Okay? So it looks like 273 has to do with combined gas law, right? So that's a combined gas, and that's a harder problem because you got to pick out your P1, V1, T1, and all of those characteristics. So glad that she picked this one out. In your book, it's on page 897 in problem 271. I'm just going to go ahead and lay out my pressure 1, volume 1, temperature 1, pressure 2, volume 2, temperature 2.
But it's 273.
I'm sorry, 273. Okay? So it'll be 273. So we're going to write in all the numbers here. All right? So a weather balloon is inflated to 2.94 kiloliters. Volume 1. At that location and where it's filled, the pressure is 1.06 atmospheres. The temperature at that time is 30 degrees Celsius. So that would be 305. Okay, don't even write Celsius in there. That way I don't get in trouble. It's going to rise up in altitude to where there's very little air. And when it gets to a certain level in the atmosphere, where there's not much air, they measure the pressure. It is 0.092. Okay? The temperature reading at that altitude would be a minus 35. So that would be maybe it'd be 238. Is that right? Is that what you guys got?
Yeah.
238? Okay, there we go. We got everything but the new volume. So we set up our problem, P1, V1 times T2. I'm just going to go ahead and already say I cross multiply. Okay? And that equals P2, V2, T1. After I cross multiply. Alright? Because normally it's P1, V1 over T1. I'm going to have everything on one level. I'm looking for V2. So I'm going to divide both sides by pressure 2 and temperature 1. So it becomes P1, V1, T2, all over P2, T1. I do that to both sides, and that's what I end up with. So I got 1.06. Volume 2.94 kiloliters. Temperature 2 is 238. Divided by pressure 2.092. Divided by T1, 305. That's what you should get. Okay, so there's two of the problems. Yes?
278.
Okay, well this will be the last one we'll do, because I want to get into a couple new ideas. So any questions on this? I'm really detailed on this. I noticed some of your papers you don't do this. Okay, that I'm kind of leaving that up to you. I'm not requiring you to show all of this. But if you're getting them wrong, I would maybe try to do something different. Maybe try to be a little bit more detailed. If I'm getting these wrong, I'm going to go, well, if there's something I'm doing wrong, I'm going to have to get things figured out a little bit better. Maybe I want to show more detail. Make sure I'm setting everything up right. Okay? The last one we'll do is 278. Is that which one you want? Okay? So this is the ideal gas law. Is involved on this one. So 278. So PV equals nRT. Okay? So we got P and V, and we don't have, we can go R, N, T. Alright. So as we go down through this, student collects 425 milliliters. I can't have milliliters. Okay? So my it has to be liters. I divide by 1,000, that's 0.425 liters. First thing I notice, I got it in milliliters, I got to get rid of that. The temperature is 24, so that would be 297 Kelvin. Okay, the atmosphere's pressure is 0.899. And then it says how many moles. So here's moles. We got to find our R value. Has to be, this is in atmospheres, is that right? So our R value has to be 0.0821. Is that everything correct, looks like? Then we got to find moles. So N equals PV over RT. So pressure 0.899 times 0.425 divided by 0.0821 divided by 297. Okay. So that's how you do it. So this is one where volume, if you use milliliters, you would be 1,000 times bigger than you should have been. You'd been the decimal would have to be divided by 1,000 to get the right answer. So you use the wrong volume. You got to be in liters when you use the ideal gas law. Okay. And I'm assuming that gets you the right answer. That's how I'm assuming that though. Okay? Okay. All right, good. I'm glad we had a lot more people do the assignment. I appreciate that. I think that's going to help you come Thursday when you have to see what you're doing wrong on these problems. And then if you get them all right or most of them right, you see you're doing things right. Okay?
Quiz on Thursday?
Mm-hmm. Yep, I said that earlier. Yep, quiz on Thursday. Okay. 1, 2, I don't have a lot of time, so I'm going to go through this real quick. I need to make a change on this problem real quick, so don't write it down until I make the change. And I'm going to show you a variation. Okay, so PV equals nRT, N is equal to moles. How do we, if I give you grams, let's say I give you 20 grams of nitrogen gas, how do we change that to moles? What do we do?
Like train
The
tracks,
gram
you
to mole
got
ratio.
20 grams.
Right, gram to mole ratio. So down here we put 28 grams because I add two nitrogen together, and that gives me 1 mole, right? Okay, so what we can do is we can substitute in 2 numbers in for N. So we're not going to use N anymore in these new problem sets. What we're going to do is use 2 units that can be used to solve for moles. So what would be the symbol would we use when we're given the grams of a sample? You may know what symbol represents grams.
G.
Yeah, I mean that symbol, but what would it be, not the unit, but the symbol that represents grams? Mass. So that would be what symbol? Little m. We go density equals mass over volume. Little m. So we're going to substitute in m, and we have to have another one so that we can solve for the moles. And so we would use a symbol for 28 grams. So what does the 28 grams represent? 28 grams per mole. What does that represent? You know, you have to look it up on the...
1 mole.
Right? So what do we call that? That where we look up a mass of something and it represents 1 mole. What do we call that?
Molar weight.
Yep, molar weight or molar mass, right? So look up the molar mass, they say, you know, and you say, oh yeah, I know how to do that. Or what's the molar mass of CO2? You calculate. 1 carbon is 12, and 2 oxygen is 32. So that's, does anybody know what symbol maybe we would use for molecular mass?
Big M.
Big M. Big M, little m. So then when we substitute it in for N equals little m over capital M. Do you guys agree with that? Does that make sense? We want to find moles. We take the mass, divide the mole by the molecular mass, and now we have a new equation where we don't have moles anymore, but we have 2 variables that we can use through an experiment. So like when you do an experiment, we usually weigh things out. Okay, and we know what gases will be produced. So we have a molecular mass and we have a mass. So knowing that information, now PV equals little mRT over capital M, right? Because little m over capital M is moles. So now we can solve for a molecular mass. And that's what we're going to do here in a second. So on your paper, find, rearrange your symbols, give you a minute to think about it, and have it set up to solve for capital M. Okay? Do that on your paper. Solve for capital M. Because that's what we're going to do in our problem. Solve for capital M. So capital M equals
Little MRT.
little mRT
Over PV.
over PV. That would be right. Okay. So did multiply both sides by capital M. Then you got everything on one level. So then divide both sides by PV. Got it. Okay. So I want you to solve for the answer, and I want you. I'm going to give a prize out if you want it. If you don't want it, then you don't have to try to do it. But what I'm going to have you do is I'm going to have you attempt to figure out what gas I have here. I don't think we'll have anybody do it, but you know, I could be wrong. I've been wrong before. Okay. want you to use that equation. Find the molecular mass of a gas that has a weight of 2 grams. And it has these following conditions. The gas is under a pressure of 80 kPa. The volume of the gas is measured to be 0.86 liters once we capture it. And the temperature of the gas is 20 degrees Celsius. Okay? So that's what you're going to have as your numbers that you're going to work with in which to find the final answer. Okay? So go ahead and attempt to find the final answer for that work. Okay? Now come around if you guys got questions. Josh, why don't you try to see if you can try to set this up and do it. The R values, if you guys did not write the R values down, I'm going to let you guys write it on your periodic table. Just write it on your periodic table. Because most of the time, when you're doing these problems, you're going to have your periodic table out anyway. Okay? It's some sort.
What page was that chart on?
I don't know. That's why I'm going to give you these, and you can just write it on your periodic table. Because you usually have your periodic table with you when you're doing problems anyway. So, if there's some things you need to work on for labs, you can do that. Make sure I get those in. There's some of you don't have that stuff in. I don't know why. We have had it done for a week, and some of you just hold on to it. Just to have a bigger chance of losing it. Some of you lose things a little bit more often than you should. So, kind of get some of that. If you need to ask some questions, yep, that one needs to hand it in. Ask some questions on how to do this molar volume lab, percent air, those type of things. You can ask those type of things. We can get those things done. Okay?